The rest of students will be joined during the session. Okay, and only a few of the students are allowed to enter in the waiting room in Zoom meeting, and rest of all will be accessed on the YouTube live link. Okay, sir. Dear friend, first of all, I heartily welcome today's resource person, Dr. Siddhartha Marupati sir, in 20th day of countrywide classroom teaching program. And topic for discussion in this countrywide classroom teaching program 21st day is the electrochemistry relevant to subject chemistry. Either it may be for the different semester in different university in Maharashtra and Andhra Pradesh also. But for our university, I think it is an for this second year, fourth semester. So I request Dr. Siddhartha Marupati sir uh, to take a charge of this session. Siddhartha Marupati sir.
Yes, sir.
My colleague, Dr. Gajanan Kottapalle, will be with us. He is assistant professor in chemistry also. So myself, Dr. Arvind Chavan, and Gajanan Kottapalle will assist you for the any urgency or any queries or any difficulty during this sessions. Okay, sir?
Okay, sir.
Regarding technical support, either addition of the yeah, okay, sir.
Yeah.
So,
Yeah.
Siddhartha Marupati, sir.
Yes, sir.
The session is over to you.
Yes, sir. Yeah. Good morning, sir. Good morning, all. First of all, yeah, I'm very thankful to providing this opportunity. Yeah, in this pandemic situation, and also for organizers of Digambar Rao Bindu Arts, Commerce and Science College, Bhokar, Maharashtra, India. And also, I'm congratulating you organizers for this effort for conducting and for creating single platform by conducting the countrywide classroom teaching program CWCP 2021, and I'm very thankful to you also. And first of all, here there's myself, Dr. Siddharth. I'm the assistant professor, Vardhaman College of Engineering, Hyderabad. Then I would like to teach this electrochemistry. I have chose this topic. Why? Because this is very, very important. The students who are there, who are studying that physics and as well as chemistry. And why? Because here, if it moves to this one, in the electrochemistry, the major things which we have covered, that which consists of generally we study about the electrons and reactions, how the chemical changes will be takes place, everything we'll study here. And first of all, if it comes to this measurements, electrical measurement of the chemical process, first we have to understand that what is the meaning of a redox reaction here. And also, you know that in our day-to-day lives, while I'm taking the class, while I'm taking this lecture, or you are listening the lecture, and that important thing to do all these things are we require the batteries. Yeah, whether you are using the mobile phone, where I'm taking that, and some laptop, you are listening by using that mobile phone or laptop or something. Generally, we require this. The main constant is required is battery here. If the battery is not there, and these conversations are this program and everything is not possible here. And the batteries which are interlinked with the electrochemistry here. If there is no electrochemistry is there is no battery. There is no battery is there, it is not possible to conduct this or to organize such type of programs here. And the battery, how it will be interlinked here. We are taking this is the best example, that battery, and which consists of anode and cathodes are present here. And anode and cathode, we are calling it as electrodes, and which converts the chemical energy into electrical energy we are using here. As you know that cars are also there. Nowadays, vehicles we are using, buses we are using, so many buses are running, so many electric vehicles they are running, and that completely depends on the battery without pollution. Here, there is no air pollution will be there if you use this battery. That much of importance is there to understand the battery. To know about the battery, we require the electrochemistry. And what are the things majorly what we required, what we have to study in the electrochemistry? There is some basic concepts are there. That is, first one is oxidation reaction, and next one is what? Reduction reaction here. What is meaning of oxidation here? Generally, what we can call it as, which is called oxidation. Oxidation meaning is loss of electrons. Here, this thing we are understanding. The second one here, we can know that we are taking that this is the second reaction we are observing. That oxidation meaning is loss of electrons. Here we are taking that Cu plus gives rise to Cu plus 2 plus electron. Here, what is the meaning here? It is losing the electron. Here it is losing the electron meaning is what we can say that we are taking that copper plus gives rise to, 1 minute, copper gives rise to copper plus 2 plus electron. Here it is losing the electron. Here it is losing the electron meaning is what? That indicates that loss of electrons, nothing but oxidation. You're observing the first case, first example. If you observe here, Fe plus 3 is converting into Fe plus 2. How it will be converted here? That oxidation number is decreasing. Oxidation number is decreasing means what? Fe plus 3 is converting into plus 2. When it is possible? By gaining the electrons. That means if you observe the reduction meaning is gaining of electrons. Oxidation meaning is loss of electrons. And this thing is very, very important. And also one more thing we have to understand. This oxidation reaction, as of that two electrodes are present. What are the two electrodes are there? That is, one is anode and another one is cathode here. As you know that anode meaning is the electrode at which oxidation reaction takes place. Nothing but the second reaction takes place. The cathode meaning is that the electrode at which the reduction reaction takes place, the first reaction takes place. If both the reactions are possible, then only the energy will be released. In case of battery, if you observe. But also in any cell meaning is electrodes and electrolytic solutions. If this is present, if this principle is involved, then only that energy will be released in any case here. If there is no oxidation or there is no reduction, it is not possible to understand here. And one more thing here. And next one here, if we consider these two reactions are there here. Here we are calling this as first one we are calling this as a half cell reaction. And second thing we are calling it as what? Another half cell reaction here. What do you mean of half cell and a half cell? Half cell and a half cell meaning is, if we consider this cathodic reaction, it is present in the half cell. Half cell meaning is the electrode, if it is present in its own ion containing solution, that we are calling it as half cell. And similarly, Fe plus 3, Fe, iron electrode is present in some solution. And second one is copper is present in some other solution. Some other solution meaning is what? Its own ion containing solution. That is, copper is present in copper sulfate. And let us consider this is half cell reaction, and this we are calling it as half cell reaction. Then half cell reaction completely we are calling it as what? Some cell reaction which will be takes place, that we are calling it as a redox reaction. It is a combination of both oxidation and as well as reduction. And in this case, energy will be liberated here. And if there is no reactions, energy will not be liberated here. For this to understand that, first we have to understand that what is the meaning of charge. Charge generally measured in terms of coulombs. Yeah, as you know that. And also here, if you consider the electron is there, electron carries some charge. What is the charge carried by the electron means what you say? That meaning is 1.602 into 10 power minus 19 coulombs here. And here, as you know that, how can we define the charge? How can we define the charge meaning is here that Q is equal to N into F. Q is equal to N into F, where Q is what? Coulombs, that current charge, we can say that. And next one is what? N indicates number of moles, and F is the Faraday of the current. Faraday meaning is 96,400 coulombs or 96,499 coulombs. And second thing, we have to understand that electric current. What is the meaning of electric current here? Quality of the charge flowing each second through a circuit. That meaning is what? Current per second. That we are calling it as what? Nothing but amperes. That is a measurement of that particular current here. And next one is what? Electrode potential, electric potential. That how can we define that? Negative work carried by during the transfer of the electrons, during the flow of electrons, that we are calling it as what? Potential. That is, we are calling it as Gibbs free energy, we can call. That Gibbs free energy is equal to, how can we calculate that? EQ. E stands for potential and Q stands for electric current. What is meaning of potential? What is meaning of electric potential? What we can know that it is a combining of charge and potential. That is, if it comes to the Gibbs free energy, it is a combination of what? Potential and charge. What is meaning of potential here? Potential nothing but we are taking that two electrodes are present, and in these two electrodes, here one electrode oxidation takes place, at another electrode, as you know, that reduction takes place. The electrode at which oxidation takes place, where the electrons are released, and those electrons moves from anode to cathode. During the movement of the electrons from the anode to cathode, some potential difference is developed in between these two electrodes. That potential difference we are calling it as what? Electrical potential, or else we can say that this is, we are calling it as electromotive force. We are calling it as what? EMF of the cell here. And this EMF of the cell is very, very important. Why? Because if the cell is working, some potential is developing, some charge is developing, some potential value is developing, means because of this particular EMF only. And this EMF is developed during that meaning is what? EMF. How can we calculate that? Each and every electrode, we are taking the half cell, and two half cells we are taking. Each half cell consists of one electrode here. Each electrode is having some potential. At anodic half cell as having some potential, cathodic half cell having some potential. The potential difference between these two electrodes, we are calling it as EMF. That can be measured by connecting the voltmeter in between these two electrodes, and that we are calling it as what? Potential. And next one is some other basic concept we'll study in the electrochemistry is electrolyte. What is the meaning of electrolyte? Whether that substance should be present in the molten state or solution state, have a capacity to allow the passage of current, simultaneously undergoes chemical transformation, is called electrolyte. As you know that here I am taking NaCl. NaCl, whenever if it is present in the water, then what it gives rise to? It gives rise to Na plus, and next one is what? As well as Cl minus. Here, if this Na plus and Cl minus they are releasing, when it is possible here, whenever the sodium chloride, if it is present in the water or if it may be present in the molten state. What is the meaning of molten state? The state which is present in between the solid and liquid state, that we are calling it as what? Molten state. Whenever this Na plus and Cl minus ions are released, and these ions are responsible for the production of electricity. And that meaning is what? And this conduct the electricity because of the presence of Na plus and Cl. If suppose we are taking the NaCl solid, if you take the NaCl solid, it does not conduct the electricity. We will not call that solid NaCl as a electrolyte. When we call that as an electrolyte, whenever this NaCl, if it is present in the molten state, or else it should be present in the form of what? Solution state. In both the states, if they are present, and that particular substance, not only the NaCl, any substance, and that we are calling it as what? Electrolyte. Yeah, and we are observing that some undergoes some chemical transformation we are taking. What is the meaning of chemical transformation? What is the meaning of chemical transformation means whenever this NaCl, if it is present in the form of solution, that is converting in the form of ions, right? That is Na plus and Cl minus. But initially how it is present? NaCl. That is combined state it is present, and it is changing into Na plus and Cl minus. That means converting into the form of ions. That we are calling it as what? Chemical transformation. That we are defining it as what? Electrolyte. And next one is here electrolyte. Generally they are classified into two types. That is based on the strength that we are that they are classified into two types. What are the two types are they? One is strong electrolyte and another one is weak electrolyte we are taking here. Strong electrolyte we are taking, and second one is we are taking that weak electrolyte. What is the meaning of strong electrolyte and weak electrolyte here? Suppose here I am taking some water, I am taking here. Here I am dissolving one electrolyte. So I am taking this NaCl is electrolyte, or else you take some HCl. This NaCl is a very best example that in our day-to-day life we are seeing, that we are calling a salt. That is the reason why I am taking this simple example to understand here. NaCl here I am taking in the water. Suppose let us consider 100 molecules, 100 NaCl molecule. Let us consider, this is the assumption here. 100 NaCl molecules, if they are dissolving in the water, suppose here, if it gives rise to 100 Na plus ions and 100 Cl minus ions. That meaning is what? If 100 molecules are, if they are dissolving, approximately 100 molecules, if you are dissociated into ions, they are dissociated into ions, and such electrolytes, we are calling it as what? Strong electrolyte. That meaning is what? 100% dissociation takes place. What is the meaning of 100% dissociation or ionization here? That how many molecules they are dissolving in the water, how much extent the dissociation takes place. If that extent of dissociation is 100%, then we are taking that is the strong electrolyte. And one more thing we have to understand, that while you are defining the strong electrolyte, the degree of dissociation value is 1. What is the meaning of degree of dissociation? It is represented with alpha. That meaning is number of molecules dissociated into ions. Dissociated into ions by total number of molecules. If the small u is 1, then we can say that strong electrolyte. How it is 1 here? Yes, we know that here we are taking 100 molecules. Total number of molecules are 100. Here in the case of denominator, we are taking the 100. How many molecules dissociate into ions? It releases 100 Na plus and 100 Cl minus. Meaning is out of 100 molecules are dissociated into ions. That is the meaning of 100 Na plus and 100 Cl minus. That numerator value, then numerator value is also what? 100. If the numerator value is 100 and the denominator value is 100, and then the value what we are getting is what? 1. And that value, alpha value, is if it is 1, then we can say that that electrolyte is strong electrolyte. Next we are taking the weak electrolyte. One more example we are taking here. Here I am taking that some water. I am taking the same quantity of the water what we have used in the previous case. The same water I am taking, but here I am taking some electrolyte like acetic acid. Some electrolyte we are taking, that is acetic acid I am taking here. And here suppose if acetic acid, if it is dissolved in the water, if I am taking, let us consider the same number of molecules here also I am taking 100. But whenever if it is dissolving in the water after some time interval, if it releases 70 CH3COO minus and 70 H plus ions are releasing here. What is the meaning of this one? What is the meaning of this one? That meaning is out of 100 molecules, they are dissolving only 70 molecules they are converting into the ions. Not 100 out of 100 molecules, they are not converting into the ions. That meaning is what? There is a partial dissociation takes place. Partial dissociation takes place. Partial dissociation meaning is what? Nothing but what? Out of 100, 70 molecules are dissociated. That meaning is what? What is the alpha value? The total number of molecules is same. There is no change. Here also total number of molecules is same. But here we are observing 100 NaCl, 100 NaCl, 100 molecules. That value is 1. But here we are observing only 70 molecules. That is 70 by 100. That meaning is what? 0.7. 0.7 is less than 1 or not here. That if the degree of dissociation alpha value less than 1, those electrolytes we are calling it as what? Weak electrolytes. If their degree of dissociation value is 1, then we are calling it as strong electrolytes. And next one, if it comes to the examples, what are the examples we can say here? What are the examples we can understand here? What are the examples are there? Here, if it comes to the strong electrolytes, the examples are the strong acids, strong bases, etc. Here. If it comes to the weak electrolyte, what are the examples means what you can take here? The examples are weak electrolytes are weak acids, weak bases, and the salts which are derived from the weak acids and weak bases are the examples here. And next, one more thing we have to understand, that what is the meaning of electrolysis? What is the meaning of electrolysis? The decomposition of an electrolyte by passing the electric current through its solution is called electrolysis or electrolysis. Meaning electrolysis. What is the meaning of lysis here? lysis meaning is decomposition. Decomposition of an electrolyte, we are defining it as what? Electrolysis process here. And power. Power meaning is work done per unit time. We are calling it as what? Power here. And this we are defining it as what? Power. We are defining work done per unit time, that we are defining it as power. And this is the strong electrolyte. And next one we are calling it as what? Weak electrolyte here. And next thing we have to understand in this case, in the electrochemistry, the important one is Arrhenius theory here. What is Arrhenius theory here? It is applicable for the electrolytic conductors. What is the meaning of electrolytic conductors? Just now we have seen that whether it may be NaCl, whether it may be strong acid, whether it may be strong base, whether it may be weak acid, weak base, all are we can consider as a electrolytes. And in the solutions, as you know that spontaneously the electrolytes are dissociated into charged particles. As we have seen that NaCl gives rise to Na plus and Cl minus. H2O gives rise to H plus and OH minus. Acetic acid gives rise to CH3, CO minus and CO3. In this ionization, in this dissociation, it releases two ions. What are the two ions here? One carries the positive charge and one carries the negative charge. With the one which carries the positive charge, we are calling it as cation. The one which carries the negative charge, those we are calling it as what? Anions. This is the point which was given by the Arrhenius here. Already you know that cation and anion, but that given by the Arrhenius while he is observing the electrolytes if they are present in the water. And we know that the electrolyte in the given solution may not be completely ionized. The fraction of the total molecules ionized is termed as degree of dissociation. Just now we have seen what is the meaning of degree of dissociation. What is the meaning of degree of dissociation here? The degree of dissociation meaning is what? The ratio of what? Number of molecules dissociate into ions by total number of molecules, we are defining it as a degree of dissociation. As we have seen there two examples. One example is with the strong electrolytes. Another example we have seen with the weak electrolytes. In case of weak electrolytes, we are observing that 70 molecules only. Not only the 70 molecules, it may be the 50, it may be the 40, it may be 30, but it is not that complete dissociation. It is not 100% dissociation. And that is that we are defining it as what? Degree of dissociation. And also we know that strong electrolytes are more completely ionized, as we have seen, and weak electrolytes are split into ions in smaller fraction. That meaning is what? Smaller fraction meaning is what? The alpha value is, that value is less than 1. That is for the weak electrolytes. These are the points they given. This is the strong electrolytes and this is the weak electrolytes. That already we have discussed in case of strong electrolytes and weak electrolytes. That was given by the Arrhenius while are explaining while it is applicable for the electrolytes. And one more thing we have to understand, that the conduction of the electrolyte increases with increase in the temperature. What is the meaning of this one here? The conduction of electrolyte increases with the increase in the temperature. Suppose here I am taking the NaCl, I am dissolving in the water. Suppose initially what happens is, suppose here 100 I am taking, that 100 molecules may not be dissociated to ions. Out of 100, initially 70 molecules are dissociated to ions. Now I am increasing the temperature. Now applying the temperature. If you increase the temperature, what happened here? Remaining 30 molecules also dissociate to ions. That meaning is what? Initially 70 Na plus, 70 Cl minus. Finally, after heating, after increasing the temperature, 100 Na plus and 100 Cl minus. In which case more conduction is possible? Yes, definitely more number of ions are present, more conductivity is possible here. But in the previous case, without applying the temperature, yes, it is also conduct the electricity, but the conductivity is less when compared with the case 2, in which case the more temperature is present, right? This we are calling it as what? Arrhenius theory here. And this we are defining it as what? Arrhenius theory here we are taking here. And next thing, galvanic cell or voltaic cell here. What is the meaning of galvanic cell or voltaic cell here? Galvanic cell nothing but the cell which consists of the two electrodes. Here we are observing on the screen. Here we are taking the two electrodes are there. What are the two electrodes are present here? This is a Here I'm taking, this is the one electrode, and this is another electrode we are taking here. These two electrodes, they are present in the electrolytic solution here we are taking. And these two electrodes are, they are connected by the voltmeter, and this voltmeter which is used to measure the potential difference between the two electrodes, as we have discussed. This is one electrode and this is one electrode. One is anode, another one is cathode here. And definitely we should understand that which is act as anode and which is act as a cathode here. And that depends on the standard reduction potential value, or nothing but we can say that that depends on the electrode potential value. The electrode potential value generally we can consider as a standard reduction potential value. What is the meaning of standard reduction potential value? Suppose here I am taking zinc is present. Zinc, if it is converting Zn plus 2, if it is take the 2 electrons, they are converting into zinc. And copper plus 2 electrons gives rise to copper we are taking. These are the examples. In this case, what is the reaction? This is gaining of electron, reduction. And the potential value is minus 0.763 volts. Here copper, this is also what? Reduction reaction. The corresponding potential value, we are taking it as 0.337 volts. If you compare these two electrodes potential values, which is having the higher value, which is having the lower value here? Definitely this is the lower value and this is higher value here. The electrodes, if you compare not only this zinc and copper, if you compare any electrodes, the electrode which is having the higher potential value, that acts as an anode, that is cathode. The electrode which is having the lower potential value, that should be act as an anode. Like this, based on this comparison, we should decide that which is anode and which is cathode. Once you understand the anode and cathode, where which reaction takes place, we know that. That is at anode oxidation and at cathode reduction will be takes place here. And the important thing here, we have to understand that how can we know these potential values? How can we know these electrode standard reduction potential values? That standard reduction potential values we can understand based on the electrochemical series. That electrochemical series meaning is all the potential for each and every electrodes, they measure the potential values based on the standard condition by maintaining the standard conditions. Based on that, we can understand that which electrode is having the which potential value, and based on those potential values, we can decide which is the anode and which is the cathode here. And this is the galvanic cell here. And also here we are to understand that here we are taking that here in the galvanic cell, here two electrodes are present. Here we are taking, this is the one electrode and this is the another electrode, and this electrode is present in some solution, electrolytic solution, and this electrode is present in the electrolytic solution. Always you remember that the electrode which is present on the left side, that should be act as anode. The electrode which is present on the right side, we should be act as a cathode. And these two electrodes are connected by a voltmeter, which is used to measure the potential difference. As you know that we have studied, that meaning is what? EMF. That can be measured by using the voltmeter. The current which is present, which is developed, the output voltage which is developed during the working of the cell, that can be measured by using the voltmeter. And also one more thing we have to understand, that in the construction, here these two half cells, this we have discussed, this is one half cell and this is another half cell. And in between these two half cells are connected by this inverted U-shaped tube, that we are calling it as salt bridge. That salt bridge which consists of K plus and NO3 minus ions. Why we are using only NO3 in the manufacturing of, in the preparation of salt bridge? Nothing but the ionic mobilities are same for the K plus and NO3 minus. And if we use salt bridge, then only it completes the circuit. It maintains the electrical neutrality in both the cases. What is the meaning of electrical neutrality here? If more number of cations are present here, then the functioning of this cell will be stops. If more number of anions are present here, then the functioning of this complete cell will be stopped. There is no working of that particular cell takes place. But how can we maintain the electrical neutrality? By passing the more number of cations. If they are here, if this moves towards here, then the number of cations decreases here. Then number of cations in this half cell is equal to number of cations in this half cell. Number of anions here and number of anions, it should be equal. But how the passage of that ions will be takes place from this half cell to this half cell? If there is no salt bridge, it is not possible. But here the salt bridge is present, then the counter that ions migration will be takes place. Then if the ions migration takes place, then electrical neutrality should be maintained. If the electrical neutrality should be maintained, then only the functioning of the cell takes place here. That is the use of what? Salt bridge here. And one more thing we have to understand, that how can we represent the galvanic cell? How can we represent the galvanic cell? Meaning is, here we are taking zinc, suppose we are taking in the zinc sulfate, copper we are taking in the copper sulfate, and this potential value is minus 0.763 and this value is 0.337. Based on this, we know that this is anode and this is cathode. As you know that the potential which is having the higher value, that is a cathode, which is having the lower value, that is the anode. Now, how can we represent this cell? This cell, how can we represent? Meaning is, anode means which reaction takes place? Oxidation. That's why first we represent the metal. The reaction is what? Zn is converting into Zn plus 2 electrons. In this case, which comes first? Metal is followed by metal ion. That's why we represent Zn/Zn plus 2. And if it comes to this is the cathode. How can we represent the cathodic reaction here? Reduction. Reduction meaning is what? Cu plus 2 electron gives rise to Cu. In this case, which comes first? Metal ion comes first, followed by the metal. That meaning is what? How can we represent? Cu plus 2 followed by Cu. Now, this is the anodic half cell we are calling. And this is the cathodic half cell we are calling here. And these two, how can we represent? We know that to complete the circuit, we require the salt bridge or not. If the salt bridge is present, then only we can call that as a cell. Now, these two, Zn/Zn plus 2, and next one is what? Copper plus 2/copper. It is separated by two vertical line. That two vertical line that indicate the salt bridge, which is used to separate in the representation of anodic half cell and as well as cathodic half cell. That is the representation of cell. Not only this cell we can represent, by using this representation we can represent for any cell, but we should identify which is anode, which is cathode based on the electrode potential values. Then only you decide that anode which reaction, cathode which reaction. Based on that we can write the representation of that particular cell here. And this is the thing, this we have to understand that how can we represent the cell. Not only this cell here, any cell like this, by using this notation we can represent here. Here on the screen it is there. Here you are observing here zinc by zinc sulfate, copper sulfate by copper. Not only here we can represent Zn by Zn plus 2. Here also we can represent Zn by ZnSO4 also we can represent. Metal followed by metal ion or metal followed by the electrolyte. Either of the way you can represent for the anodic half cell. Similarly, copper plus 2 by copper, nothing but what? Copper sulfate by copper. Either of the methods we can use to represent the electrodes. To represent the electrodes, we can use any one of the method here to represent the electrodes here. And here you know that standard potentials. What is meaning of standard potentials? As just now I have discussed that each and every electrode, whether it may be the metals or non-metals, if they are present in its own ion containing solutions, by maintaining the standard temperature and pressure conditions. What I mean of standard temperature and pressure conditions here? There is 25 degrees centigrade room temperature and 1 atmosphere pressure. And if the solution is present as electrolytic solution, definitely some solution is present. We have to maintain that solution as 1 molar concentration. For each and every electrodes, whether it will be non-metals or metals, by maintaining all these conditions, that one series will be developed. That series we are calling it as what? Electrochemical series. Here you are observing on the screen, the different values are present. For the fluorine, the value is 2.89. For the oxygen, the value is 2.075. For manganese, the value is 1.507. For silver, 0.799. Like that, how they are arranged here? They are arranged in the decreasing order here. These potential values which are arranged in the decreasing order, and that is we are calling it as what? Electrochemical series. Based on this electrochemical series only, we decide which is anode and next one is what? Which is cathode. And one more thing, we have to understand that how can you calculate, how can we calculate this EMF of the cell. EMF of the cell meaning is what? The potential difference which is developed in between the cathode and anode here. That how much voltage is generated by any cell. How can we measure here? How can we know that? How can we calculate? By using the E cell value. You know that cathode and anode. Anode is present left side, cathode is present on the right side. This electrode is having some potential. This electrode is having some potential. Anode is having some potential. Cathode is also having some potential. That the potential difference between these two electrodes, we are saying that is the E cell value here. Here we are taking that. Here one example is there here. Here you are observing here. That is cadmium, which is having the lower value or higher value here. This is having the lower value. If you observe the silver, which is having the higher value, here it is having the higher value. Here it is having the lower value. If you compare these two, which is anode and which is cathode? Yes, this is definitely anode. Why? Because the required conditions that should have the lower value. Here it is having the lower value, that is anode. And here it is having the higher value, it acts as a cathode. Now, you observe that E cell value meaning is E cathode minus E anode. What is the cathode here? Silver. What is the value of this cathode? 0.78. Here I am writing the 0.78 instead of this one. 0.78 minus, this is a minus E anode. What is the anode we are using here? Cadmium. What is the anode potential value? Minus 0.461. Here, then minus 0.461. Then what is output? What we are getting? 1.242 volts. That E cell value, we are getting the value as what? 1.24 volts. And that is a way, that is a method we can calculate the E cell value. And one more thing we have to understand, whether this particular cell is working or not. That also we can identify based on the E cell value. As you know that if E cell value, if it is positive, then the cell will be, functioning of the cell will be takes place. Or else we can say that the cell reaction is spontaneous. If E cell value, if it is negative, then we can say that is non-spontaneous. The functioning of the cell will not be takes place. And how can we decide that? That also we can know that based on the Gibbs free energy. Delta G is equal to minus NF delta E naught cell. We can take. Here in this, you know that N is number of electrons which is involved in the reaction. Always it should be positive. F is Faraday, just now we have discussed, 96,500 coulombs. This value is also positive. This is positive, this is positive. As you know that delta G always it should be negative. When this it should be becomes negative, N should be positive, F should be positive, and E naught cell also positive. That is the reason why whenever if you get E naught cell value as positive, then you get the delta G negative, then the functioning of the cell takes place. Then the working of the cell takes place. Then we can say that reaction is spontaneous reaction here. That is the meaning of what? Spontaneous, and next one is what? Non-spontaneous here. And next one here. And we know that Nernst equation here. What is the meaning of Nernst equation? This is very, very important key thing in the electrochemicals, electrochemistry here. What is the Nernst equation? Which is used to calculate, which gives the relationship between the EMF and the concentration of the reactants and the products here. That meaning is what? We can calculate by using Nernst equation. We can calculate the single electrode potential. Also, we can calculate electrode potential of the cell. We can calculate. For that, what we are using the formula, we are using it as what? E is equal to E naught minus 2.303 RT by NF log concentration of products by concentration of reactant. Suppose here I am taking the reaction as AA plus BB gives rise to CC plus DD. What is capital A represents? Those are the reactant. Capital A is reactant, capital B is reactant, capital C is product, capital D is product. What small represents here? What small a, small b, small c represents here? These are the number of moles. Here, suppose if we consider this is the reaction, we are applying the number of this is the Nernst equation. If you apply to the above equation, then it becomes what? E is equal to E naught minus 2.303 RT by NF log of products. What is the product here? Capital C, power small c, capital D power small d by capital A power small a into capital B power capital B small b. That indicates what? Equilibrium constant. What is the meaning of equilibrium constant? Again, concentration of products by concentration of reactants, we are calling it as equilibrium constant. Concentration of products, nothing but what? C power C. Why we are writing C power C here? That is C, reactant power number of moles. Generally we can write here. That we are calling, that is the Nernst equation. By using Nernst equation, we apply it to the any equation here, whether it is the redox reaction, or it may be the oxidation reaction, or it may be the redox. If you apply the oxidation reaction, what is the meaning of oxidation reaction? That when it takes place by using the single electrode. Single electrode. That meaning is what? If you apply for the single electrode, if you apply for the oxidation, if you apply for only the reduction reaction, that potential value we are calling it as what? Electrode potential. If you are applying for the redox reaction, redox meaning is what? Anode and cathodic, both reactions are present. Then we can get the E cell value here. If you apply for the single electrode, we can get the E electrode potential. If you apply for this AM equation, then if you apply for the complete reaction, redox reaction, then you get the E cell value. And one more thing we have to understand here. Here, if you apply that, what is meaning of R? That indicates the gas constant. That is 0.0821 joule per mole per Kelvin. And T is what? Temperature, room temperature 25 degrees at 298 kelvins. N is number of electrons. One F is Faraday. If you apply this R value, T value, and F value, N means it depends on the reaction here. E is equal to E naught minus, if you all values, if you substitute, then we get the equation is modified as 0.0591 by N log of C power C into D power D by A power A into B power P. That equation is modified like this by substituting that R value is gas constant, that is 0.0821, T is the 298 Kelvin, F is 96,500 coulombs. By all values, by substituting, we get that value here. And next thing here, then we have to understand here, after discussing the Nernst equation, that equilibrium constant already we have discussed. This is the galvanic cell, and here this one, it's already we have discussed these things, potential. And next we have, this is important, the concept in the electrochemistry is Ohm's law here. What is Ohm's law here? That Ohm's law meaning is, then we are applying that, you know, that conductor, you know, that cell. Already we have discussed the cell. The cell meaning is what? It consists of two electrodes are present. Here it is one electrode, and here it is having the another electrode. Two electrodes are present. Two electrodes are present in some solution, and these two are connected by a voltmeter, which is used to measure the potential difference between these two electrodes. What is according to the Ohm's law? You know that resistance. What is the meaning of resistance? Resistance, conductance meaning is what? Conductor meaning is what? The substance which is allows the passage of electric current, we are calling it as conductor. The property of the conductor we are calling as conductance. Resistance meaning is what? Resistor meaning is what? Which does not allow the flow of current. Resistance meaning is what? It is a reciprocal of conductance, we are calling it as what? Resistance. Reciprocal of resistance is called conductance. Reciprocal of conductance, we are calling it as resistance. As you know that every cell which conduct the electricity, at the same time, the cell is also having some resistance value. And that particular resistance is directly proportional to L of the cell. What is the meaning of L? What is the meaning of L? That L indicates, here we are observing the cell. Here there is a distance is there in between the two electrodes that represent the L. That is the resistance of this particular entire cell. The resistance of the cell is directly proportional to distance between the two electrodes. That is, we are representing with L. And similarly, the resistance of the cell and inversely proportional to area of cross section of the electrode. As you know that here I am taking the electrodes. Here electrode we are taking. Electrode is having some area. That area, that meaning is what? Either of the electrodes we are taking. What is the meaning of either of the electrodes? The area of both the electrodes is same. That is the reason why we are taking that either of the electrode. If you consider the resistance of this particular entire cell, that is inversely proportional to either of area of either of the electrode here. That is indicates what? R is inversely proportional to 1 by A. From these two equations, what we can understand, this is 1 and this is 2. From 1 and 2, what we can write? R is proportional to L by A. And R is proportional to L by A. Then we have to introduce the proportionality constant. What is the proportionality constant we are introducing? R is equal to rho into L by A. R is equal to rho into L by A. That rho indicates what? Specific resistance here. Again, here we are taking this equation. Here it is there. The reciprocal of this equation we are taking here. The reciprocal of this equation becomes what? 1 by R is equal to 1 by rho into this one here. And based on that, we get K is equal to C into L by A. What is K here? That indicates specific conductance. What is C? That indicates conductance. What is L by A? L is constant, A is constant. This is applicable for the cell. That we are calling it as cell constant. The meaning is what? Specific conductance is equal to conductance into cell constant. Here, if it comes to the units, what do you know that resistance units are what? Ohms. Conductance units are what? Reciprocal of resistance. 1 by R. 1 by R meaning is what? Here I am taking 1 by R. Resistance is conductance is equal to 1 by R. 1 by R meaning is what? 1 by ohm. 1 by ohm meaning is what? Ohm inverse. These are the units of what? That conductance. Next, specific resistance is not required. Specific conductance. If you know the specific conductance, what is specific conductance here? K. K is equal to what? C into L by A. C units, you know that. What are the C units are there? Ohm inverse. And into L, distance. Distance generally what? How can we measure here? By using centimeters or meters. If it comes to the CGS, that's centimeters here. Centimeters. By area. Area, how can we measure here? Centimeter square. Centimeter by centimeter square. Centimeter inverse. The meaning is what? Ohm inverse, centimeter inverse are the units of what? Specific conductance here. And L by A. L by A is what? Cell constant. What are the units of cell constant? Meaning what do you say? Centimeter by centimeter square. That indicates what? Centimeter inverse. These are the units of what? Specific conductance. Specific conductance is defined as what? Conductance into cell constant here. Cell constant is defined as what? The distance between the two electrodes by area of cross section of the electrodes. That we are defining it as what? Cell constant. That is L by A. And this we are calling it as what? Ohm's law here. And this is the Ohm's law which we are studying in the electrochemistry here. And next one is we have to understand that what is conductance, what is specific conductance, and what is equivalent conductance, what is molar conductance. As you know that, I'll tell one example, then you can understand here simply here. You know that here I am taking the NaCl. Here I am taking the water. If NaCl, if it is dissolving in the water, if it is dissolving in the water, that how many ions are present? Those many ions causes the conductance. That means, suppose here I am taking the 100 Na plus 100 Cl minus. This because of the total ions present in the solution, the total ions are responsible for the production of electricity. That is defined as conductance, right? That is the definition of the conductance. The meaning is what? The substance, if it is present, the conducting power of all the ions present in the solution. The conducting power of all the ions meaning is what? Conducting power nothing but what? Charge carried by the ions. The charge carried by the ions, we are defining it as what? Conductance. Do you clear this? And next one is specific conductance. What do you mean? The same example I am taking. Let us consider. Here I am taking the NaCl. Here I am dissolving in the water. But let us consider this solution. NaCl in the water means NaCl solution that is divided into the different cubes. That entire solution is divided into some cubes. Let us consider it is divided into 10 cubes. In these 10 cubes, if you consider one cube volume is what? 1 centimeter cube volume. This particular 1 centimeter cube, how many ions are present? And those ions are responsible for the production of electricity. That we are defining it as specific conductance. Now I think you understood that the difference between the conductance and specific conductance is what? That conductance is applicable for the total solution, but specific conductance, specific is the meaning. What is the meaning of specific here? It is not applicable for the entire solution. It is applicable for the 1 cubic part of the total solution. If it is divided into 10 cubes, out of 10 cubes we can consider 1 cubic centimeter solution. In that centimeter cubic, 1 centimeter cubic solution, how many number of ions are present? Those many number of ions, if it is causes the conductance, that we are calling it as what? Specific conductance here. And next thing we have to understand that equivalent conductance. What is the meaning of equivalent conductance here? Here same example I am taking here. Here I am taking that NaCl. Here I am taking some water. I am preparing the NaCl solution. But while we are preparing this NaCl solution, there how much NaCl we have to take? 1 gram equivalent of an electrolyte we have to take. 1 gram equivalent of an electrolyte meaning is what? That 1 gram equivalent. 1 gram equivalent. As you know that, which you can understand based on the normality concept. Number of gram equivalents of solute which is present in the solution, we are calling it as one normality here. Molarity meaning is what? Number of moles of an electrolyte present in the 1 liter of solution, we are calling it as molarity. That is number of moles, number of gram equivalents here. That number of gram equivalents, suppose you are taking the 1 gram equivalent of an electrolyte. Here we are mentioning the specific weight of the electrolyte. In the previous case, you are not concentrated on the how much sodium chloride we are taking here. How much sodium chloride we are taking, but we are taking some sodium chloride only we are telling while you are defining. But here you are taking while you are defining the electrolyte gram equivalent of that is equivalent conductance. Specifically, we are mentioning that 1 gram equivalent of electrolyte we are taking. Whenever we are taking 1 gram equivalent, definitely if this electrolyte, if it is dissolving in the water, it dissociates into ions, and such ions are responsible for the production of electricity. That we are defining it as what? Equivalent conductance. And meaning is what? What is the difference you are observing in between the conductance, specific conductance, and equivalent conductance? Here in case of conductance and specific conductance, we are not mentioning the quantity of the electrolyte what we are taking. But if it comes to the equivalent conductance, the electrolyte quantity you are measuring, that quantity you are taking, the quantity you are specifying here, how much you are taking, and also we are mentioning that as what? 1 gram equivalent. If 1 gram equivalent of an electrolyte, if it is dissolving in the solvent, then it releases the ions. Those ions are responsible for the conductance, and that conductance we are defining it as what? Equivalent conductance. And that is what we are defining, that equivalent. And molar conductance. What is molar conductance here? Instead of if you take 1 gram equivalent, if you take 1 mole of equivalent, 1 mole meaning is what? Avogadro number of molecules. Avogadro number of molecules meaning is what? 6 into 10 power 23 molecules if I take, and that 6 into 10 power 23 molecules, they are dissociated into ion. The meaning is what? What is the difference between that equivalent, gram equivalent, and 1 mole here? That number of moles we are taking here. That is different for the different species we will define here. Here we are taking the number of, instead of gram equivalent, we are taking 1 mole. 1 mole of an electrolyte, if it is present in the solution, and how many ions are present because of the dissolution of this particular 1 mole of electrolyte, and that conductance we are calling it as what? 1 molar. If it is gram equivalent, if you take, that is called equivalent conductance. Instead of 1 gram equivalent, if you take 1 mole of an electrolyte, 1 mole of NaCl, if it is dissolved, that ions will be released, and how many ions are released, and those ions are responsible for the production of electricity. That we are defining it as what? Molar conductance here. And the thing we have to understand that what is the difference, what is the effect of dilution here? What is the effect of dilution here? As you know that as a dilution increases, number of ions increases. As the number of ions increases, then what we can say that conductance also increases. Why? Because conductance depends on the number of ions, and this is applicable for the conductance, equivalent conductance, molar conductance, but it is not applicable for the specific conductance. As the dilution increases, conductance, equivalent conductance, molar conductance will be increases, but here we are observing the specific conductance decreases. Why? Because that if you compare with the whole solution, in the specific conductance, we are taking specific part you are taking. As the dilution increases, decrease in the number of ions in the 1 ml solution. 1 ml meaning is what? That particular cubic solution contains the less number of ions. Why? Because that will be distributed throughout the solution, not present in the specific area. If they are not present in the specific area, means definitely the number of ions are less in the specific area or not. And due to that reason, the number of ions are less in that particular specific cube. Due to that reason, the specific conductance is decreases. But if we consider the conductance, equivalent conductance, molar conductance, all will be increases here. And next thing we are observing, that next concept is that that is Kohlrausch law here. What is Kohlrausch law here? What is Kohlrausch law means? At infinite dilution, each ion contributes its fixed value towards the equivalent conductance. As you know that what is equivalent conductance, how can we represent? Lambda, we can represent the equivalent. Lambda AB. AB is electrolyte. That meaning is what? Lambda infinity of A plus and lambda infinity of B minus. Suppose lambda HCl, lambda infinity of H plus, lambda infinity of Cl minus. That means the sum of the equivalent conductance at infinite dilution of that particular both ions, that is H plus and Cl minus. Suppose if you are taking the lambda NH4OH, that is lambda infinity of NH4 plus, lambda infinity of OH minus. Suppose we are taking the lambda HNO3, lambda infinity of H plus, lambda infinity of NO3 minus. And what is the meaning of infinite dilution? That is also important. What is the meaning of infinite dilution here? Infinite dilution meaning is, suppose here I am taking the 100 NaCl molecules. I am taking same example you have took. Here I am adding 100 NaCl molecules are present here. I am adding the water, 10 ml water I am adding. Only 10 molecules are converted into the ions. Remaining 90 are there. One more 10 ml I am adding. 10 plus 10, 20. One more 10 ml, 30. One more 10 ml, 40. Like that. If we add the 100 ml, let us consider 100 molecules are dissociated into ions. If the 100 molecules are dissociated into ions, further we are adding the water. Any molecule is present to undergo dissociation? No. Why? Because out of 100 molecules we have taken, 100 molecules are dissociated into ions. Even if you add further water, there is no molecule is dissociated into ions. And that particular dilution, we are calling it as what? Infinite dilution here. Further, there is no splitting of the molecules into the ions takes place. That we are calling it as infinite dilution. Equivalent conductance, if you take, that is having the infinite dilution, lambda infinity. As you know that lambda infinity of AB, lambda infinity. If it is for the ions, we are calling that as a ionic conductance. And next one is what? What is the uses of the Kohlrausch law? What are the applications of Kohlrausch law? Meaning is here by using the Kohlrausch law, here we can calculate the conductivity of at infinite dilution for the weak electrolyte, and also we can calculate the degree of dissociation. We know that what is meaning of degree of dissociation, and also we can calculate the dissociation constant, and also we can calculate the solubility of sparingly soluble salt. And here these are the four are the applications of what? This particular Kohlrausch law here. And that we can calculate these are the application. That is the reason why that Kohlrausch law developed this here. And this is my presentation. And stay home and stay safe. Thank you so much. Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you very much, sir, for presentation on electrochemistry. We have covered all the aspects, areas of the electrochemistry. I hope our student got clear their ideas. Now it's time to say thanks. I request, with hoping that you will be available for another lecture.
On what day, sir?
Yes, sir.
Yes, sir. Sure, sir. Sure, sir.
Yes, sir. Yes, sir. Sir, we are continuously continuing this activity for our student as this pandemic lockdowns were ongoing, and were not sure about the reopening of college as earlier.
Yes, sir. Yes, sir.
So
Really,
yeah,
really, you are doing the great things, sir. Sir. So
yes,
my
yes.
appreciation towards you, sir. That
Yeah,
always I'm with you, sir. And anytime you can, if you are there, if you are conducting, just intimate me, sir. Definitely, I'll be
okay,
part of your wonderful programs. Thank you, sir.
okay.
Thank you so
Thank
much.
you, thank you, thank you very much, sir. Hoping with you will be available. I hand over this session to my colleague, Mr. Gajanan Kotapalli, sir, Assistant Professor in Chemistry, to propose a vote of thanks for this sessions. Gajanan Kotapalli, sir, session is over to you.
Thank you, Dr. Arvind Chavan, sir. I am here to cast a vote of thanks. Today we have Dr. Siddhartha Marupati from Vardhaman College of Engineering, Hyderabad. And sir has explained today electrochemistry. In his presentation, sir has focused on the electrical measurement of chemical processes, Arrhenius theory, galvanic cell, standard oxidation potential, Nernst equation, effect of dilution, Molar. Sir has explained these all points not only with PowerPoint presentation but also with using board. So these two methods definitely I hope our participant will understand electrochemistry very nicely and they enjoyed today's session. So I would like to thank Dr. Siddhartha Marupati sir for giving time from his busy schedule, and we hope in next few days also sir will give next lecture on another topic. So sir, you are explain electrochemistry in simple way by using board also. So once again I thanks to Dr. Siddhartha Marupati sir for giving us your valuable time. I also thanks to Dr. Arvind Chavan sir
Thank you, sir. It's not the time to teach. Sir, I'm audible.
Yes, sir. Yes, sir.
for
Thank you, sir.
attending the.
Okay.
Now I hand over the session to Dr. Arvind Chavan.
Okay. Thank you, sir. Thank you. Thank you very much. Thank you, Siddhartha, sir.
Thank
Hope
you,
to
sir.
see
Thank you,
again.
sir. Thank
Yeah.
you, Arvind, sir. Yeah, sure,
Yes,
sir.
sir.
Sure, sir.
Take care.
Definitely.
Stay home.
Stay home, stay safe, sir. Thank you, sir. Thank you so much.
Yes, sir. Thank you. Thank you very much.
Bye, sir. Bye, sir. Bye.
Yes, sir. Bye. For the participant, we will be tuned at 12 o'clock with our another session on exotic fishes. Thank you. Thank you very much for joining this session. Hope to see you again at